Hello, students. I want to say thank you to all of you who showed up online to take your test. I am working on getting your homework graded, and then I'll work on your quizzes, and I hope to have those in there by tomorrow. But I do appreciate you showing up when I asked you to, and hopefully you found that it was not anything surprising on there. So we're going to continue on with this unit of curve sketching and look at the next piece, which will be something called concavity. So basically, concavity is where the graph changes from where it's curving up to curving down. And the place where we have a change in concavity is called a point of inflection. So you'll see that we have this idea of concave up, and I think it's just where I'll kind of circle here on the graph. There's where the graph is concave up, kind of like a smile. Here's where it's concave down, like a frown. And then you'll see that where it changes from concave up to concave down, I have a point marked here. And that point where we change concavity is called the point of inflection. And a lot of times I'll just abbreviate that as POI. So a point of inflection, and you can see that in all of the graphs here where there is a change in concavity, you have a place, a point where that happens. And even on this last one where we have the change in concavity at this point of inflection. So to determine the concavity of a graph through analyzing it, we will look at the second derivative. And so the test for concavity is as follows, that if your second derivative, so make sure you realize this is f double prime, if your second derivative is positive, greater than 0, then your original function f is concave up. And likewise, if your second derivative is negative, so less than 0, then f is concave down. And if you have a change from concave up to concave down, then you have a point of inflection. So it's where that concavity of the graph changes. And so points of inflection will be found much like how critical numbers are found. You will take your second derivative, not the first one, but the second derivative, and set that equal to 0, or look for where that second derivative is undefined. And then those are possible points of inflection for the graph. So I wanted to do just an introductory session, and I'm actually going to skip, if we'll go on to the second page, I'm going to skip where I have given you some information about a second derivative test, and I'm going to have us just take a look here at these steps, and then I'm going to go through an example. So depending on what you're asked to do, you will definitely need to find your first derivative, and in this assignment, you'll have to find your second derivative. If you're just focusing on concavity, then you'll create tables that will include your intervals, the sign of f double prime, and then your conclusion or your characteristics of f. And then this is just kind of a repeat of what we established before that. So in section 4 here, kind of a repeat that double prime being positive is concave up, double prime negative, concave down, and looking for consecutive sign changes from up to down, you would have your point of inflection. Number 5, I will come back to when I do the video on the second derivative test. So this is just a short introductory video. I'm going to have you go ahead and move to your example page, and I'll put that on a separate video.